So the z-score of a data value tells you the number of standard deviations from the mean, right? So that score of a 20 that I just talked about on the regions, that would have a z-score of -2 because it was 2 standard deviations under the mean. You guys probably can you've been figuring out z-scores on your own. You've been figuring out how many standard deviations away is that on your own. So do you really need a formula? It doesn't seem like you do unless the z-score is not working out nicely. So if the mean of a set of math tests is 86% with a standard deviation of 3, then an 80% corresponds to a z-score of what? So here's your 86. And then 3 below puts you at 83. 3 more below puts you at 80. So what's the z-score of that? -2. The z-score is how many standard deviations it is. So z-score of -2. And that's what I'm talking about. We've been doing those already. Now, if you wanted to use the formula, your z-score is your data value. That's what the x sub I is, and our data value was 80, minus the average, so minus 86. So pretty much they're figuring out how far above or below is it, right? Over the standard deviation, 3. So the 80 minus 86 tells us that our data value is 6 points below the average. And if each standard deviation is 3, then that equates to -2, or 2 standard deviations below the mean. So we've been figuring these answers, these z-scores out. Number 1, without knowing what a z-score was. We weren't calling it that. Number 2, without formula. You don't have to have these things. The formula is only going to be nice if it doesn't work out nicely to 1, 1.5, 2, 2.5. Okay? All right, in the next exercise, boys' heights in 7th grades are normally distributed with a mean of 62. I still prefer an image. I don't know if that means I'm a visual person, but I'm just going to give you that visual perspective in case that helps you too. So mean height of 62, standard deviation of 3.2. This is an uglier standard deviation. So if I go up 3.2, I'm at 65.2. Up another 3.2, and I'm at 68.4. If I go down 3.2, I'm at 58.8. Down 3.2 more, I'm at 55.6. Oh, thank you. Find the z-scores of each of the following heights. So this is tougher. Like if I did 66 right here, I know that the z-score is over 1, but not 2, right? And it's not landing perfectly at 1.5 either, right? So we would definitely just use our z-score calculator. So 66 is the data point, minus the average of 62, all over the standard deviation of 3.2. So this is 4 units above the average, which is why we get a positive 4, divided by 3.2, and that z-score is a little over 1, right? 3.2 goes into 4, a little over 1. 1.25. And see, what you're obviously going to find is that our chart that we dealt with yesterday, it also doesn't break down percentages on the 1.25 level. I'm sure there's one out there that is more detailed, but we're going to use our calculator here in a minute to do these problems. 57 would be 57 minus the average of 62, all over the standard deviation. That numerator tells us that our score physically is 5 points, 5 inches below the average. Divide by 3.2, negative 1.5625 would be our z-score. And again, on our chart from yesterday, negative 1.5 point something would put you over here somewhere, and it doesn't really give us the specifics of the percentages below that. Olivia? Yes. The chart would be given to you. Well, but truthfully, after today, probably not, because I'm going to show you how to do this on your calculator, so you don't really need the chart anymore. All right. So exercise 2. Jeremiah took a standardized test where the mean score was 560. Standard deviation was 45, so I'm just going to go up 1 to 605 and down 1 to 515. If Jeremiah's score resulted in a z value of 1.84, then what was his score? So what is 1.84 standard deviations above the mean? I'm not going to tell you how to do this. Raise your hand when you figure it out and I'll give you bonus points. Morgan? Well, the mean is 560. I want to know the equivalent score that would equate to being 1.84 above the mean. 643. How did you get that? You must have set up an equation. What formula? Oh, so you plugged in a z value of 1.84. You're looking for your data value minus your average was 45 all over a standard deviation of 560, sorry. So he just plugged in what he knew and he did it algebraically. Okay, so he multiplied for, so that, what did you get? X equals what? Okay. I'll give you bonus points. That's not really, I was thinking more conceptually, right? 1.84 means you're 1.84 standard deviations above the mean, right? 1.84 standard deviations is 1.84 times 45. So I was more thinking 1.84 standard deviations would be 82.8 above the mean. And what's 560 plus 82.8? 642.8. And you said 643, right? Would yours technically have given you 642.8? It did. Okay. So I was more thinking conceptually. I think a lot of you could have figured that out. He did it algebraically and just jumped right to the formula. It all still works. Okay? Jump to 3. Lengths of full-grown sockeye salmon. Any fishermen in the group? Fisherwomen in the group? I don't even know if that's how you say it. Sockeye salmon? Is that right? Okay. Are normally distributed with a mean of 29.2. Standard deviation of 2.4. So I'm just going to go up 2.4 to 31.6. A lot of times I draw this, I don't really actually need it. It just gives me pause and time to figure it out. And like not try to rush to the answer, which causes problems. Using z-scores, determine the proportion, not the percentage, not the number, but the proportion of sockeye salmon population. Oh, I guess they are turning the proportion into a percent. I was going to say proportion and percent are very closely related, but to the nearest percent that lies between 26 and 32. So, okay. 26 is not going to be a nice number of standard deviations, right? It's a little over 1, but it's not 1.5 because 2 standard deviations, 26.8, if I subtract 2.4 one more time, puts me at 24.4. So 26 isn't going to be 1.5 below. So it's not a nice z-score, right? And truthfully, on your calculator, Well, I'll show it to you. So let's calculate the z-score of this. So 26 has a z-score equal to, and I'll just do 26 minus my average of 29.2 all over my standard deviation of 2.4. So the z-score of that lower limit is 26 minus 29.2 divided by 2.4. Negative 1.3 repeating. And on the upper end, 32 inches would be a little over 1 away, right? So 32 inches is going to have a z-score of, and we'll figure it out exactly, 31 minus the average divided by the standard deviation. So that's 1.8. What'd I do wrong? I was going to say that it should be over 1. I already realized it should be over 1 because I plotted it there. So that's 2.8 divided by 2.4, which is a little bit over 1 standard deviation. 1.16 repeating, right? So here's what your calculator can do for you. Everyone needs their calculator. Because again, your chart isn't going to give us those percentages. Negative 1.3 and positive 1.16 kind of is cutting off partial parts of these different interval bars. Yes? We could ballpark it, but that's never good in math. So it looks like it's going to be somewhere around, I don't know, 38, 40, 70-ish, 72%. I'm not exactly sure. But we don't have to be sure because our calculator does it for us. So there's this button, VARS, and above that VARS it says DISTR. Guess what DISTR stands for? Distribution. And that's really what the normal distribution is. So we're going to hit second VARS and NormCDF. And what the NormCDF allows you to do is it allows you to plug in your, so if we're trying to find the percentage that are between these two levels, this z-score would be our lower limit, negative 1 point, and hit a bunch of 3s. So we want to go from 1.3 repeating z-scores below, and our upper limit, we want to go 1.1 and then hit a bunch of 6s. We want to go up to 1.16 repeating standard deviations above. In the world of z-scores, your average has a z-score of what? 0, right? So your mean is 0, and your standard deviation is 1, right? So 1 standard deviation, and then this is the 1.16 repeating. 1 standard deviation below, and that's the negative 1.13 repeating. So if in the world of z-scores, and I'm going to write this down, it would be NormCDF of your lower limit, comma, your upper limit, comma, your mean of 0, and your standard deviation of 1. And when I do that, it's going to tell me the percentage of these salmon that fall within that interval. Do you follow? Enter. It brings it to my calculator, and it's in that form. And then I hit enter, and there's my percentage. 70, well, that's the proportion technically. Convert it to a percentage, it's 78.7%. Morgan. If you're using z-scores, yes. Okay? So in the world of z-scores, yes. Because in the world of z-scores, 0 is always your average, and like a standard deviation of a z-score of 0 would correlate with your average, and 1 is your standard deviation. Jack. Okay, bring it over and I'll see what happened. Okay, so, but here's my thing. I'm never going to do this again. I don't see the point of changing it to z-scores because on your calculator you can also take the actual numbers and do the same thing. You can do your lower limit, which they said was 26 inches, to your upper limit, which they said was 32 inches, your actual average of the size of these salmon, which was, what was the average? Why are you looking at 29.2, and your actual standard deviation that they told you was 2.4. Type in those numbers, and you should also get 78.7. So my question always has been, well, why would I bother changing it to z-scores, right? So you're going to do second VAERS again, and go to NormCDF, and lower, upper, mean, standard deviation. Okay? In case we don't know that, this symbol is the mean, and this symbol is the standard deviation. Because you went from negative 1.3 repeating to negative 1 point, and that's a positive 1.16. So if you just got rid of that, so you only gave yourself, you went from like here to here. So that's why your percentage was so low. But make that a positive, and then voila. Okay? Anybody else have trouble with their calculator there? If you have, there's a way. I'll just have to work with you separately. Okay. All right. 2 more things here. A proportion that measures less than 25. So if you think about a normal curve, and here's your 25, and you want to be less than 25, that's technically going towards infinity, right? What number could you use? So if you do second VAERS, and I'll do this for B, I'm going to do NormCDF, what number can you use for your minimum if you want it to be negative infinity? Only my 4-year-old was here. He's obsessed with infinity right now, and he'll tell you 9999999. If you want it to go on forever and negative infinity, just start it at negative 99999. It's just forever. Up to 25 with a mean of 29.2 and a standard deviation of 2.4. And you'll get your proportion of 0.04. So your lower limit, if you're on like the lower end of the graph, is negative 999. You can do that as many times as you need. And then your upper limit is 25 inches. Your mean is still the 29.2, and your standard deviation is still the 2.4. And that gives us 0.04 for part B. If they wanted that as a percentage, 4%. Okay, so that's part B. Part C is going to be similar, but they want greater than 35. So they're not spelling out a lower limit and an upper limit. They're just saying greater than 35, which is from 35 on the low end to infinity. You follow? So norm CDF, your lower edge is 35. Your upper edge is technically infinity, which we know a fish is never going to be 9999999 inches long, but who cares? It's just going to give you the rest of the graph. It's going to give you everything above 35 with a mean of 29.2 and a standard deviation of 2.4. So you would just type that in, second VAERS, change your lower and your higher. Low is 35, high is 9999999. And 29.2 and 2.4 haven't changed because we're still in the same problem. And we get 0.0078. is what percent? 0.78%. So not even 1%. 0.78% is the equivalent to 0.0078. So if they ask for the proportion, 0.0078, the proportion as a percent, 0.78%, which you have to understand is less than 1%, which is not a lot of fish, being greater than 35 inches. So as much as I love z-scores and like it makes sense, and if you're using this chart, it's definitely necessary if it's going to be like a 1 or a 1.5, but you don't even need the chart anymore. You have your calculator. You can always do NormCDF. Follow? Okay, homework's coming around your spiral you picked up on the way in.
I got my homework.
Thank you. Oh, and why don't you go through this thing? And tell her if it's not enough time now, ask her if you can come back before you go to Potter.